Voyager to turn its camera back towards Earth, and it was basically amounts to Earth's first ever selfie. And that picture was taken, and there was this pale blue dot.
NASA's Voyager 1 spacecraft is in interstellar space.
This is the spacecraft, the first to interstellar space. We made it.
Hello everyone and welcome back to Universal Narratives. We're never going to stop exploring the unknown in air and space. Voyager, in some very real sense, is material that's not from the medium in which it finds itself. I was hearing the first of the two Voyager spacecraft extend man's set is farther into the solar system than ever before. The Earth may be a massive and beautiful place, but in comparison to the rest of the universe, it is a mere speck. Scientists just made a terrifying discovery in the Euphrates River. NASA just found something incredible in the galaxy that will change our lives. Scientists just found Zeus's god temple sealed for thousands of years. Ever since human technology made it possible to launch rockets and satellites into space, people have had an insatiable desire to learn more and more about the mysteries of the universe. Well, with the Voyager delivering us information to process and, well, it's just sent us a dreadful warning and it's about to change everything. Join us as we analyze all the Voyager that has discovered up at this point. Also, along with a terrifying message and what it might mean for the future. For almost 45 years, the Voyager missions have been an integral part of space exploration, providing some of the very first and most significant glances into the true state of our solar system. Yet these missions were never intended to survive this long. When the first plans for the probe were carried out, the idea to send out probes in the late 1970s was created out of sheer accident when Michael Minovich that a spacecraft could piggyback on the velocity of the planet and catapult further out in the future of solar system. The probe can detect when something is wrong, Dodd says, as Voyager 1 wades through the edge of our cosmic lake where the magnetic field of the sun interacts with the interstellar medium in ways that are not yet to be fully understood. Things might happen. This hinterland is ripe with astronomical data that has yet to be harvested. So the old machinery on Voyager 1 needs to be able to take care of itself. It has a lot of ability to autonomously detect what's wrong and put itself in a safe situation, Dodd said, remarking on the current situation. But it isn't gone into any kind of fault protection, which tells us that the spacecraft thinks it's just fine. It's just that, for some reason, it started speaking a different language that we don't understand, she says with a laugh. According to NASA officials, the Voyager mission was planned to last 5 years when it was first launched. However, both Voyager 1 and Voyager 2 are still on the move, gathering crucial scientific data from the deepest reaches of space. In the summer of 1977, the two spacecraft launched within weeks of each other. Voyager 1 and Voyager 2 were designed to explore Jupiter and Saturn. Both spacecraft successfully carried out studies of those planets. Later, Voyager 2 completed the first ever close observations of Uranus in 1986 and Neptune in 1989. The flyby trips involving the four planets became known as the Voyager Grand Tour. After that, the two spacecraft embarked on a new mission to explore distant reaches of space. NASA revealed in 2013 that Voyager 1 had crossed the boundary separating our solar system from interstellar space. The term interstellar means between stars. According to scientists, interstellar space begins where the sun's continual flow of particles and magnetic fields cease. Voyager 1 is currently navigating through interstellar space. It passed the border of the solar wind's dominion in space, called a heliopause, back in 2012. However, the spacecraft is still within the sun's gravitational grasp and hasn't left the solar system. Yet. As Voyager 1 treads along the edge of our cosmic home, scientists hope the spacecraft will get off its lawn and go even further into outer space. But the more distance it treks, the older it gets. It's a whopping 14.5 billion miles from Earth now because it's been flying across space at a pace of roughly 3.6 Earth distances each year in recent years. And it's the history. Voyager 1 launched on September 5th, 1977, 2 weeks after its twin robotic mission, Voyager 2. Initially, they traveled in the same direction to rendezvous with the outer planets, but they veered off onto different trajectories after swinging past Saturn in 1980 and 1981. According to NASA, Voyager 2 eventually entered interstellar space in 2018. At the moment, the spacecraft was 17.7 billion kilometers from the Sun. So far, the Voyagers are the only spacecraft that have explored interstellar space. The two explorers investigated how the interstellar medium interacts with solar wind, the Sun's continual flow of charged particles. They have also supplied information about the heliosphere, which is a protective bubble that surrounds our solar system. The solar wind creature is the heliosphere, which is molded and changed by interstellar circumstances. The actual border of the solar system, the place where solar wind ends and interstellar space begins, is called the heliopause. According to NASA, the Voyager spacecraft has supplied fresh knowledge about interstellar space. They discovered, for example, that cosmic rays are approximately 3 times more intense beyond the heliopause than deep with the heliosphere. Scientists merged Voyager findings with data from subsequent missions to obtain a more complete picture of our sun and how the heliosphere interacts with interstellar space. As per NASA, last year scientists announced the Voyager 1 had recorded a humming noise that was linked to waves identified to minuscule amounts of gas found in the near emptiness of interstellar space. Nicola Fox, the director of NASA's Heliophysics Division in Washington, D.C., stated in a statement that the Voyager's missions have supplied significant information about the Sun and the Sun's influence throughout the solar system over the past 4 decades. Experts are still puzzled as to how Voyagers can continue to operate in temperatures well below what they are built for. Scientists have also detected something weird going on in the solar system's outskirts. The heliopause, which is a barrier between the heliosphere and the interstellar medium, appears to be ripping and creating oblique angles in an unexpected way. The general concept that the heliopauses change shape is not new. Over the past decade, researchers have determined that it is not static. They made this discovery using data from the only 2 spacecraft to leave the heliosphere thus far, Voyager 1 and Voyager 2, as well as NASA's Interstellar Boundary Explorer satellite, which studies the emissions of energetic neutral atoms produced when solar winds and the interstellar medium interact. The Voyager spacecraft provide the only direct in situ measurements of the locations of these boundaries, but only at one point in space and time. Eric Zernstein, a space physicist at Princeton University, wrote in an email to Vice, "IBEX helps round that data." Scientists have used the data to develop models that forecast how the heliopause will change in the future. In a nutshell, solar winds and the interstellar medium push and pull on each other to form a constantly shifting boundary. The statement didn't provide any additional information about the signal it caught. NASA has been investigating a strange glitch that has caused Voyager 1 to send back nonsense data about its location in space. NASA first reported the glitch in May, although it is not specified when the issue began. The agency is confident that the spacecraft is safe because if the gibberish data were accurate, the signal from Voyager 1 wouldn't be properly pointed towards Earth. However, recent heliopause research has revealed data that contradicts prior findings. IBEX documented the brightening of ENAs that suggested asymmetries in the heliopause over a period of many months in 2014. And the scientists later found such asymmetries were incongruent with the models Vice reported. Furthermore, scientists observed that the heliopause shifted substantially in a relatively short amount of time after studying data from Voyager 1 and Voyager 2. That explains why there was such a significant gap between the 2 probes' entries into interstellar space in 2012 and 2018, respectively. However, the heliopause's movement also contradicts the theories. The researchers called these disparities entry-speaking and potentially controversial in an article published October 10th in the journal Nature Astronomy. I hope you enjoyed the video. Don't forget to hit that subscribe button. Thanks for watching and see you in the next video.